So here we will talk about what a complex fraction is and how to simplify it. So first of all, what is a complex fraction? A complex fraction is a fraction that contains fractions. Okay? Sounds complex, right? Well, it is. Most people don't like fractions the way they are, and if you put fractions within a fraction, then it can be really confusing. But the concepts you learn with fractions apply to complex fractions also. So we're going to look at two different types of examples here. So occasionally a complex fraction is simply one fraction over another fraction. Okay? So for example, and we'll work this example out later, but this is an example of a complex fraction. X plus 1 over x squared minus 9, that fraction, over 2 over x plus 3. So we have a fraction over another fraction. And notice that this fraction bar here is larger than the others. So what that does is that separates our numerator from our denominator. Okay? So that's what we mean by it's just one fraction over another fraction. Those are the easiest to work with. But sometimes we have fractions added or subtracted on top and fractions added or subtracted on bottom. This complicates things. So what I mean by that is, for example, 2 over w plus 3, this fraction, minus 2, and that whole thing is a numerator. So that whole thing over 3 over w squared plus 6w plus 9. Notice this is not a fraction over a fraction now. We have two fractions subtracted on top. Remember, you can think of 2 as a fraction by putting it over 1. But we have a fraction minus something on top, and on bottom we have a single fraction. That's different than this example above. Okay? So hopefully you understand what a complex fraction is now. We'll address how to simplify each of these two types. However, you could use one method to do both. For example, the method we'll learn for this one up here will work for this guy down here also. And we'll look at a method for this guy that could also be applied to this guy up here. Okay? But I'll show you the best way, in my opinion, my humble opinion, to do this one, and I'll show you the best way, in my opinion, to do this one on the bottom as well. Let's get started. We'll start with a simpler example. What I want to point out first of all is that fractions just mean division. So when you have a fraction over a fraction, you can literally rewrite it as the top fraction, x plus 1 over x squared minus 9, divided by, so we're just changing this big fraction bar here to a division symbol, divided by the bottom fraction. And we should already know how to divide fractions. You simply take and change it to multiplication by the reciprocal of the second fraction. So change 2 over x plus 3 to x plus 3 over 2. And then to multiply fractions, you just multiply straight across. So I have x plus 1 times x plus 3 over 2 times x squared minus 9. Notice this is all multiplication, so we look to cancel. Remember, when we're trying to reduce a fraction, we try to cancel common factors. So we have to change everything to multiplication and cancel. However, x squared minus 9 is not completely factored down, so let's go ahead and factor that down further. So we carry our 2, and x squared minus 9 is x plus 3 times x minus 3. Since everything's multiplication, we can cancel the common factor of x plus 3, leaving us with a final answer of x plus 1 over 2 times the quantity x minus 3. So this complex fraction here simplifies to this standard rational expression. And the way we did this one, since we had a single fraction over a single fraction, was we just treated it like a division problem because it's very simple to do. Let's look at a harder example. So in this complex fraction, we don't have a fraction over a fraction. So we don't want to change this we can't change to division and then use the reciprocal idea, okay? So instead, what we're going to do is we need to multiply by a form of the number 1. Alright, this is an expression. There's no equals here, so we can't change its value. We can only do things that won't change its value. Well, multiplying by 1 will not change its value. But 1 has many forms. Which form do we want to choose for 1? Our goal here, we're going to multiply by a form of 1. Sorry, we don't need the comma. That will cancel all the little denominators. Let me show you what I mean by that. So the little denominators are the denominators within the fraction. So w plus 3 and w squared plus 6w plus 9 are the little denominators. We want to cancel those. Alright? So we have to multiply by something that's going to cancel those. Well, in order to figure out what to cancel them, we need to factor them so we can see what we're trying to cancel. Well, w plus 3 does not factor. But w squared plus 6w plus 9 factors as w plus 3 times w plus 3. So now we're trying to cancel w plus 3 and all of w plus 3, w plus 3. So we use w plus 3 times w plus 3 to cancel. W plus 3 times w plus 3 will cancel w plus 3, and it will also cancel w plus 3 times w plus 3. Now if that's confusing, let me just show you how to do it over here, and maybe it'll make more sense. So we have to multiply this fraction by a form of 1. So this thing, whatever it is, has to equal 1. And we want w plus 3 times w plus 3 to be in there. So I'll make that my numerator. If this fraction has to equal 1, then my denominator also has to equal w plus 3 times w plus 3. Notice here that my big fraction bars line up. So what we're doing is we're multiplying. To multiply fractions, you just go straight across. So what I'll end up doing is multiplying this numerator by this numerator, and I'll multiply this denominator by this denominator. Okay? Let me get rid of some of that so we can see a little better. So what we end up doing is taking this numerator times this guy. Well, since this minus is here, I have to distribute all of this to this fraction and to the negative 2. On the bottom, there's no distribution because I just have a fraction. So I'll take this fraction times w plus 3 times w plus 3. Okay, so on top, what we have is 2 over w plus 3 times w plus 3, w plus 3. Since 2 over w plus 3 is a fraction, I'll write w plus 3 times w plus 3 as a fraction also. To do that, I simply put it over 1. Minus 2 times w plus 3, w plus 3. Notice I didn't write w plus 3, w plus 3 as a fraction here because 2 was not a fraction, so there was no need. On the bottom, I have 3 over w plus 3, w plus 3 times the red guy, w plus 3, w plus 3, but I'll write it as a fraction since it's being multiplied by a fraction. And now, this is the key, now we can cancel stuff. Alright? So, each of the multiplications, things are going to cancel, except for this one in the top right because there's no fractions. So I'll cancel inside this red circle and I'll cancel inside this red circle because that's where my multiplications are happening with fractions. So here in the top left, w plus 3 cancels, and down here both w plus 3's cancel. So I simply end up with 2 times w plus 3 minus 2 times w plus 3, w plus 3, which if I multiply that out, I get w squared plus 6w plus 9. And on the bottom, I get 3 times 1, which is just 3. So my denominator ends up being very nice, actually. Okay, so I hope that makes sense so far. Now we need to finish. All my fractions are gone. This is no longer a complex fraction. I don't have any fractions within the fraction. So now, since I have the top is not multiplication, it's subtraction, I need to get rid of my parentheses and combine all my like terms to see if this fraction reduces. So I'll distribute my 2, and I'll distribute my negative 2. So I get 2w plus 6 minus 2w squared minus 12w minus 18 all over 3. Combining like terms and putting in descending order, I have negative 2w squared. Then I've got 2w minus 12w, that's negative 10w. And I've got 6 minus 18, which is negative 12, all over 3. So let's go ahead and factor the top, because I'm trying to reduce if possible. I can pull a negative 2 out on top, leaving w squared plus 5w plus 6, all over 3. And then the trinomial factors as w plus 2 times w plus 3, and we can see that there is no factor on the top that will cancel with the factor of 3 on bottom, so we are done. So the original complex fraction simplifies to this. The way we did it was we had to multiply the original complex fraction by something that would cancel the little denominators. Then we distributed it into the top and the bottom, cancel the denominators, and clean up the fraction at the end. One thing that students forget a lot of times is before you try to figure out what's going to cancel everything, make sure to factor any denominators. It's much easier to see what's going to cancel if you factor the denominators first. So in this case, we factor w squared plus 6w plus 9. Okay, this last example I'm not going to talk through. I'm going to work it out here in a moment, and then all the work will be here for you to look at, and I'll talk you through it without having to write it all out, just in the interest of saving some time in this video. Okay, so in this problem, the denominators, the little denominators here, can't be factored, so we can go ahead and determine what's going to cancel them. Well, sorry about that. xy will cancel x, y, and x. Those are the three little denominators. So the form of 1 that I choose here is xy over xy. Now, since I have a plus and a minus on the top and the bottom, xy is going to distribute on the top and the bottom this time. And then, when I multiply 1 over x by xy, I write xy as a fraction by putting it over 1. I do the same thing when I multiply xy by y, and I do the same thing when I multiply xy by y squared over x because it's a fraction. However, here I don't write xy as a fraction because x is not a fraction, so I don't need to. Okay, so now once I've done that, I can cancel within each of my multiplications with fractions. These three places here I can cancel on the top and the bottom. Sorry, I don't know why that keeps jumping around there. And so all I'm left with is y plus x on top, and on bottom x times y is x squared y, minus y squared times y is y cubed. Now I'm just trying to simplify this rational expression. Notice this is not a complex fraction anymore. There are no fractions within this fraction. To reduce a rational expression, I have to factor. On the bottom, I factor a y out, and then x squared minus y squared is a difference of squares, which factors using conjugates. And then I notice that y plus x and x plus y are the same thing, so they cancel, leaving 1 over y times the quantity x minus y. So there we go. Here's another example where we multiply by the appropriate form of 1 to cancel all the little denominators, and then simply reduce the resulting rational expression.